So the question that everybody will have is, and always confuses students, is that what is a resultant force? Right? Students always confuse that resultant force is actually a name of a certain type of force, such as friction, such as tension, or such as buoyant force, or such as air resistance. But actually what students do not know that actually resultant force is the actual understanding of it is that it is result of certain forces, result of forces. Just like how we get results by adding 1 plus 1 we get a 2. So by the resultant force is actually by adding or subtracting forces, we get a result of those forces. So that result is known as a resultant force. We know that forces are all vectors. So since forces are vectors, we can always represent these forces in terms of an arrow and a line, where the arrow shows the direction the force is acting, and the length of the arrow represents the magnitude of the force. So for example, let's say if we have a force of 20 Newton and we would like to represent it with an arrow and a line. So we can choose a scale to represent this. So let's say, for example, we choose 1 centimeters represent 5 Newton. So that would mean that the force of 20 Newton can be drawn with a line of 4 centimeters in length, and if the force is acting to the right, then we can represent an arrow on the line pointing to the right, where the length of this line is 4 centimeters. So this line and arrow is a vector which represents the force that we have, which is 20 Newton. So knowing that, we can come up with an idea of the resultant force. So let's say the basic of that resultant force, basic idea. So of course, if we want to find the result of any forces, we must have at least 2 forces acting onto an object. For example, let's say there is a box which is being pulled by one person to the right with a force of 5 Newton, and there is another person pulling the box also to the right with a force of 4 Newton. So as a result, the box will move to the right. Box will move to the right. That is, logically we know that, right? But since the box is moving to the right, what is the resultant force that causes it to move to the right? That would mean that we need to find the result of the forces that are acting onto the box. So the result of these forces, we can realize it based on the idea of addition of forces I'm sorry about that, or it can be subtraction, but we will go with addition first. So why we call it addition? Because both forces are acting in the same direction. Same direction. So as long as they are acting in the same direction, doesn't mean to the right or to the left. As long as all of the forces that you are concerned are acting in the same direction, we will add those forces. for the case that we have above, the 5 Newton force, which is acting to the right, we can try to draw it or realize it based on the scale diagram that we have covered earlier. So let's say we choose a scale. 1 centimeters represents 1 Newton force. So that would mean the first force that we can draw will be a 5 centimeters line. And it is pointing to the right. So this line will be 5 centimeters in length. And since it is being added on with the 4 Newton force, which is also to the right. So that means we can actually add on this line with a 4 centimeters line, also acting to the right. And as a result, the length of the line that we have now, combination of both of the lines, is actually a 9 centimeters line, which is also pointing to the right. So that would mean now our resultant force will be equals to a 5 Newton force added on with a 4 Newton force, which will lead you to a 9 Newton force. And according to our scale, 9 Newton represents 9 centimeters line. So which is also given by our drawing. So by understanding these basic ideas of vector addition or addition of forces, we can come up with the result of our forces, which is known as resultant force. So now as a practice question, why don't you try? So as a practice question, imagine that there is a box which is being pushed to the right by a 10 Newton force, and at the same time there is another person who is pulling it with a 5 Newton force. What would be the resultant force for this case? Let me give you a moment to think about the answer. Right? If you have came up with the idea of 15 Newton to the right, well, congrats, you have the right answer. Right? We can also realize this based on our drawing, based on the vectors drawing, where you can choose a scale first, because for drawing you need a certain length for the line, so you need to have a scale to draw the line. So let's say we choose the scale, which is 1 centimeters represents maybe 1 Newton. You can choose any other scale if you want, but this will be the basic scale that we can choose. So you can draw a 10 centimeters line, which represents the 10 Newton force. And you can join it with another line which is 5 centimeters in length, which represents the 5 Newton force. So as a result, you will have a line which is the combination of the length of both of the lines. Total will be 15 centimeters. And since we know that 1 centimeter represents 1 Newton, so 15 centimeters will be representing 15 Newton. And the direction is still to the right, because both of the forces that are being added are pointing to the right. Right, I hope you have learned a good idea on resultant force for basics resultant forces. We will go into another part of it where we will be including some negative forces also, and we'll see the resultant when we have forces acting in different directions. Thank you so much, and I'll see you guys again in the next video.